Welcome to a video for lesson 37, and the topic is areas of combined polygons. And you can tell by the figures that are shown that what we're talking about here are polygons that are joined together to create just weird shaped figures. So in this case, of course, we've got this rectangle here broken up by that line there, and then of course we've got the triangle attached to it. To find the area of some of these polygons, what we can do is we can just divide the polygon, actually that should say by dividing, into smaller parts. And then we find the area of each part and we add them together, right? So at this point, if you need to pause the video so that you can copy down these notes and draw these figures on your page, I recommend you do that. So that you have the figure for your notes and it's detailed. So again, pause now and then come back and watch the video to confirm. All right. In this first polygon, in example 1, what we're going to do is we're going to take it and we're going to break it apart right here. It's fairly easy to see that what we've got is a rectangle that is 8 by 4. And again, we're trying to find area, right? And the rectangle that's 8 by 4, I'll say the area of the rectangle is equal to that 4. I'm sorry, I said 8 times 4. It's 6 times 4. This 8 here is the entire length of the polygon, which means this piece is 6 centimeters, and that leaves this piece to be 2 centimeters. Got to be careful there. All right, so 4 times 6, not 4 times 8. And that gives us, of course, 24 square centimeters, because it's centimeters times centimeters. All right, then we've got the area of the triangle. And the area of our triangle here is 1/2 base times height, right? 1/2 base times height. And again, that's just this generic regular formula for the area of a triangle, always 1/2 base times height. And our base is 2, while our height is 4. So 1/2, 2 times 4, 1/2 of 2 is 1, times 4 is just 4 again, and that's still centimeters squared. So the total would be the sum of these two things. The total area is 24 plus 4, 28 square centimeters. I'm going to run out of space. Let me scoot this over. So 28 square centimeters. Final answer here. All right, it's a pretty straightforward problem. All we had to do was split it so that we had a rectangle and a triangle, found the area of each individual piece, and then we added them together. All right, this next one jumps it up a notch. It says to use a calculator, and I know you don't have calculators on you, but to be honest with you, you can talk to the substitute and ask to use the calculators that are sitting on the shelf in the classroom by my desk, on the bookshelf. There are plenty of calculators there. You can borrow a calculator to do this problem. It says use a calculator to estimate this lot. So it says lot. That means this is supposed to represent maybe a parking lot or something like that. And once again, we're going to break it apart. And the reason why we're going to use the calculator is coming here in a second. Again, if you need to pause the video to copy it down, go ahead and do that. We're going to break this rectangle or this figure up right there so that we clearly have a triangle attached to a rectangle, and we can also clearly see that the area of the rectangle is 100 times 60, which of course is 6,000 square feet. It's feet times feet, so square feet. And then the area of the triangle is where we are going to run into some trouble, because in order to find the area of the triangle, we need 1/2 base times height. I wanted to make that a triangle. All right, we need 1/2 base times height, but we don't have the base. All right, what we do know is that the height, this is our height h, the height is equal to 100, so it's 100 feet in this case. But what we don't have is the base, and we have to find it. Anybody have any ideas on how to find it? If this is 100, this is our unknown, This is a Pythagorean theorem problem. So the Pythagorean theorem says that 100 squared plus x squared has to be equal to 110 squared. All right? So 100 squared, of course, is 10,000. 10,000 plus x squared equals 110 squared. I've got a calculator here off to the side. 110 squared is 121,000. I should have known that off because it's just 11 squared with the extra zeros on it. But anyway, 121,000. If we subtract 10 squared equals, when we subtract the 10,000, 121,000 minus 10,000 is 21,000. I'm sorry, is 121,000 minus 10,000. It's been a long day and I am super tired. 121,000 minus 10,000. 2,100, yeah, that makes sense. 2,100. And it does say to estimate, all right? It says to estimate the area. And the question then would be, what number do we have to square to get close to 2,100? Well, if we have a calculator, we can estimate our final answer, to be honest with you. It comes out to about 45.8. 46 squared is 2,116. And 45 squared is 2,025. So this is somewhere between 45 squared and 46 squared. So if x was 45, we wouldn't quite get to 2,100. If x was 46 and we squared it, we would get just over 2,100, but it's closer to 46. So we're going to say that x is approximately 46. And of course, that's our base. So that's going in right up there. All right. Again, we had used the Pythagorean theorem to try to estimate x. And now that we know x is 46, approximately, now we can do 1/2 base times height, and basically it's half of 46 times 100, or you could say half of 100, which is 50, times 46, which gets you 2,300. And that is, again, square feet. All right, so with that, a lot of work being done here. This Pythagorean theorem was necessary in order to find the base. Now we have to add them together. So our total area, I'll say area is equal to 2,300 plus 6,000, which is 8,300 square feet. All right. I want to pause the video here for these two lessons, and then these two examples. The next two examples are going to be on the next video.